This is a video for GCSE Geography, Restless Earth, AQAA specification. So I'm going to start with the structure of the Earth. You don't need to know too much about it, but this is the crust and it's the thinnest part of the structure of the Earth. It's split into slabs called tectonic plates, and they move as they float on the upper part of the mantle, which is here, and it's semi-molten, the upper part is semi-molten, but the bottom part is more solid. And the semi-molten upper part has convection currents, which causes these plates on the crust to move. And as I said, this is the mantle, this is the outer core and the inner core, but you only really need to know about the crust in some form of detail. So the types of crust, you need to know about oceanic and continental crust. The oceanic crust, as you can see by my amazing drawing, is much thinner. It's about 5 kilometers in thickness, so they're in length. And then the continental crust is much thicker, about 40 to 70 kilometers in length. And the oceanic crust is more dense at 3 grams per centimeters cubed, whereas continental crust is less dense at 2.7 grams per centimeter cubed. And oceanic crust is much newer. It's about 200 million years old, and that might seem quite old to you. It did to me, but in geological terms it's quite young. But continental crust is 1,500 million years old, so it's much more older. Oceanic crust is made of basaltic rock, and continental is made of granite rock. Oceanic can sink and can be renewed or destroyed, whereas continental cannot sink and cannot be renewed or destroyed. A classic exam question is to give differences between the two types of crust, so you really need to know that. So plate margins. One of the plate margins is the destructive plate margin. This is basically where the plates move together due to convection currents. If one crust is oceanic, so this one here, and the other is continental, this one here, the oceanic crust sinks below the continental crust as it's more dense, and this process is known as subduction. However, I've got a diagram for that, for the oceanic and continental, so that's there. However, if both plates are continental, they collide instead of sinking beneath one another, which is known as a collision boundary, and it's a different type of destructive margin, but I haven't got a diagram for that. I forgot to get that, but you can just look it up. Another two types of plate margins are the constructive plate margins and the conservative plate margins. So a constructive plate margin is a result of two plates moving apart. This usually occurs on the oceans, and cracks and fractures form between plates where there is no magma as the oceanic plates move apart from each other. Then magma forces its way into cracks and makes its way to the surface to form a volcano. Land is formed as plates gradually move apart. So that's a diagram for the constructive plate margin. The conservative plate margin, on the other hand, is where the plates slide past each other. They either slide past each other in the same direction but at different speeds, or past each other but in opposite directions, as shown by the diagram here. Due to the fact that they slide past each other in different directions and speeds, they tend to get stuck, so this causes pressure to build up, which is eventually released, and this sudden release of pressure causes an earthquake to occur. At this plate margin, crust is not made nor destroyed, and also there's no magma, so volcanoes do not form. So fold mountains. Fold mountains are found in the highest areas of the world. They're very young, at approximately 65 million years old. For example, Mount Everest at 8,850 meters tall, and all peaks over 7,000 meters are in Central Asia. Fold mountains ranges include the Himalayas, the Andes, and the Alps, and we'll have a look at the Andes as a case study. The Cambrian mountains are less high due to erosion, as they are much older fold mountains. So, how are fold mountains formed? Well, when the tectonic plates collide, sedimentary rock build up between the plates folds, and forced upwards to form mountains. This means that fold mountains are formed at destructive plate margins and places where destructive margins used to be. You can get a fold mountain in two ways: when a continental and oceanic plate collide, such as in the Andes, or when two continental plates collide, such as in the Himalayas. Areas where fold mountains are situated have high mountains which are very rocky with steep slopes. Also, there is often snow and glaciers in the highest parts, with lakes in the valleys between the mountains. So, ocean trenches. They are formed near fold mountains below the ocean. Fold mountains can also form as subduction zones. This is where the continental crust folds as it meets the oceanic crust, and the oceanic crust sinks beneath the continental crust. Also, the oceanic crust sinks below the continental crust, as I said. Here, the sea is very deep, which is where ocean trenches are present. And I've got a diagram here to show you that. So, a case study for fold mountains. So, the three main uses for the Andes fold mountains are for farming, hydroelectric power, and mining. So, I'll start with farming. Mountain slopes are used for farming despite its high altitude. In Bolivia, for example, subsistence farmers grow a variety of crops, mainly potatoes, on the slopes, as they use terraces, which provides flat land which retains water. And terraces are basically steps cut into hillsides to create areas of flat land. It also limits the downward movement of soil where the soil is thin. Most crops are grown in the lower valleys, and some of the main cash crops in these valleys are soybeans, rice, and cotton. Llamas are synonymous with the Andes. They carry materials for irrigation and buildings into inaccessible areas. They also carry 25% of their own body weight, which is around 125 to 200 kilograms. Male llamas carry materials, whereas female llamas are used for meat and milk, and the wool is used to make clothes and rugs. So, mining, the use of mining. There's a range of important materials in the Andes, and is one of the top 10 countries for tin and silver. That's Peru. Forgot to mention that. Over half of Peru's exports are from mining, and the Yanacocha gold mine is the largest in the world and is a joint venture with a US-based mining company that has a 51% share. The mine is open pit, and its gold-bearing rock is daily loosened by dynamite blast, which is then sprayed by cyanide and gold is extracted. However, this can contaminate water. So, and this little bit still belongs to mining here, just couldn't fit it. So, Cajamarca is a town near to the mine and has increased from a population of 30,000 to 300,000, which provides jobs but can lead to lack of services such as hospitals, as obviously there's too many people, they can't provide for all of them. Finally, hydroelectric power. The advantage to it is that the steep slopes and narrow valley to limit farming for HEP. They're more easily dammed than wider valleys, and steep relief causes a more rapid flow of water to generate electricity. However, a disadvantage to this is that in the spring, snow melts to increase water supply, but this can vary throughout the year. For example, the El Platanal hydroelectric power plant started generating electricity. It costs $200 million and it involves a huge dam across the Canet River. So now, volcanoes. They're found at destructive and constructive plate margins. At the destructive plate margin, the oceanic plates sink into the mantle, by subduction. It then melts and becomes destroyed. As a result, a pool of magma forms in the magma chamber. Then the magma rises through the vent, which then erupts and forms a volcano. At the constructive plate margin, magma rises up into the gap, which is created by plates moving apart, which forms a volcano. So there are two types of volcanoes you need to know about: composite and shield volcanoes. So composite volcanoes, they're built up of layers of ash and lava. They occur at destructive plate margins. They have steep slopes and narrow bases of approximately 24 kilometers in length. It contains a secondary cone on its slope where the secondary vent leads to. Eruptions do not occur often, but they are violent when they do. They have a pyroclastic flow, which is about 400 degrees in temperature, and the pyroclastic flow is built up of lava, rock, dust, and hot steam. I don't think you actually need to know that in detail, but I think it's quite good to show off your knowledge to the examiner. And an example of a composite volcano is Mount Fuji in Japan. Shield volcano. It's built up of layers of lava, not ash. It occurs at constructive plate margins, is quite shallow and has gentle slopes with a wide base of around 400 kilometers in length. It's low and has a rounded peak. Its lava is also really runny and fast flowing. Eruptions are frequent but are non-violent, and an example of this is Mauna Loa on the Hawaiian Islands. So here are two diagrams to show you that. And then supervolcanoes. It's basically a mega colossal volcano that erupts at least 1,000 kilometers cubed of material. Its characteristics is that it's much bigger than ordinary volcanoes. Again, it emits at least 1,000 kilometers cubed of material in comparison to an ordinary volcano, which emits only 1 kilometer cubed. So if you think about it, one volcano is quite disastrous, so times that by 1,000, that's pretty much a super volcano. They're large depressions called calderas, which marks the collapsed magma chamber. I'll go into detail in a minute. And they're flat, basically. And calderas is basically cauldron in Spanish. So, the formation of a supervolcano. Magma rises upwards through cracks in the crust. This forms a large basin just below the surface. The pressure of this magma causes a circular bulge on the surface, which is several kilometers wide. Eventually, this bulge cracks, which creates vents for lava to pass through. The lava then erupts, which causes earthquakes and sends up massive clouds of ash and lava. Then, the magma basin empties and the bulge collapses as it is no longer supported, which spews up more lava. Once the eruption has actually occurred, a caldera is left where the bulge is collapsed. The global consequences of supervolcanoes. There are only a few supervolcanoes on Earth, and the last one erupted 74,000 years ago. A supervolcanic eruption would emit thousands of cubic meters of rock, ash, and lava. A thick cloud of superheated gas and ash would flow from the supervolcano at a fast speed. It would destroy pretty much everything and in many miles radius from it. Ash will shoot kilometers into the air and block out almost all sunlight all over the world. This could lead to global warming as conditions get very cold, and potentially lead to ice ages too, as less heat energy from the sun gets to the earth. Now, when people hear global warming, they associate it with the world getting really hot, but in this case it's the world getting very cold. And finally, that ash will also settle in hundreds of square kilometers of buildings and fields. An example of a supervolcano is the Yellowstone National Park in Wyoming, USA, but it also covers Montana and Idaho, but originally it's officially associated with Wyoming. So tourists admire the Norris Geyser Basin of the supervolcano in Yellowstone, but they do not know its potential consequences. There is evidence that magma below Yellowstone is shifting as the caldera is bulging up beneath Lake Yellowstone. There are also signs that there is increasing activity at Norris as the ground has risen by 70 centimeters in some places. It is believed that the magma chamber below Yellowstone is 80 kilometers long, 40 kilometers wide, and 8 kilometers deep. However, it is unknown as to whether magma is sitting on other materials, these of which would be necessary for a disastrous eruption. So this particular supervolcano, 2 million years ago, 1.3 million years ago, and 630,000 years ago has erupted, and if it was to erupt today, it would obviously be a catastrophe. So the effects of a supervolcano, pretty much this Yellowstone supervolcano, but in general anyway, it's likely to destroy 10,000 kilometers squared of land. It would be likely to kill 81,000 people, and 15 centimeters of ash would cover buildings within 1,000 kilometers. 1 in 3 people affected would die. The ash would affect transport, water, farming, and electricity. Lahars, which are mud flows, would be likely to appear, and if the Yellowstone supervolcano was to erupt, ash would reach the UK within 5 days. Also, global climate change would occur, crops would fail, and many people would die. And down here is just a picture of the Norris Geyser Basin, and as you can see, it's quite flat. So now moving on to earthquakes. The characteristics of earthquakes is basically the epicenter, shock waves, and focus. This is a 3D diagram. That's the word of an earthquake. You might have seen 2D ones in a textbook or somewhere else, but I find this one much more easier. So here is the epicenter. It's the point at the Earth's surface immediately above the focus, and the focus itself is the point in the Earth's crust where the earthquake begins. The deeper the focus, the less the damage. And these things here are shock waves, which are basically seismic waves, which is a better term, generated by an earthquake that passes through the Earth's crust. Now, measuring earthquakes, we use the Richter scale or the Mercalli scale, but the Richter scale is much more common. So this is a scale that ranges from 0 to 10 based on scientific recordings of the amount of movement. Logarithmic nature means that there is a tenfold increase each time. This means that a scale 2 earthquake would be 10 times stronger than a scale 1 earthquake. Thus, a scale 3 earthquake would be 100 times stronger than a scale 1 earthquake. So there are massive gaps between each number on the scale. The Mercalli scale is a scale that uses subjective descriptions to measure the effects of an earthquake using Roman numerals from 1 to 12. So where do earthquakes occur? They occur on the constructive, conservative, and destructive margins. On the destructive margins, pressure from the subducting plate sinks, and the subsequent melting triggers strong earthquakes as large amounts of pressure are suddenly released. Conservative margins, plates slide past each other and tend to get stuck for a long time, which causes stress and pressure to build up. When the pressure releases, it is very sudden, and this quick release often results in powerful earthquakes. Constructive margins, earthquakes are less severe as the friction caused by plates moving apart is less intense. So I'm going to go through 2 case studies, case study 1 and then case study 2. So the LEDC Haiti earthquake, which occurred on the 12th of January 2010. So just some key information for this particular case study. It occurred at 4:53 p.m. local time in Haiti. It was a magnitude of 7 and the epicenter was 25 kilometers west of the capital Port-au-Prince. So causes of it, Haiti lies on the Caribbean and North American plates. Stress built up along these conservative plates, and when the stress was released by a sudden spillage along a fault which runs parallel to the plate of boundary of Port-au-Prince, it triggered an earthquake really, and the fault is called Enriquillo Plantain Garden Fault. So I got a little key here. The stuff in red is primary effects and the stuff in blue is the secondary effects. So primary effects, 230,000 people were killed, 1.6 million people were made homeless, 180,000 homes were destroyed, 5,000 schools were destroyed, electricity, water and sanitation services were disrupted, as well as communication systems, which are roads and railways, etc. Secondary effects, all homeless people were given accommodation in squalid camps. These had limited water and sanitation services. Water became contaminated with typhoid and cholera. Disease also spread due to dead bodies rotting in the streets. 90 million cubic meters of rubble and debris covered Port-au-Prince, and the total cost of repair was $11.5 billion, which occurred for the period of the next 5 to 10 years. So the earthquake occurred in 2010, so repair is still going on right now at this moment. So responses for the earthquake, again, stuff in red is primary responses and stuff in blue is secondary responses. So firstly, primary responses. Many search and rescue teams from overseas came to help. Specially trained medics, sniffer dogs, and high-tech heat-sensitive equipment were flown in to help the people of Haiti who were affected by the earthquake and to rescue those trapped in destroyed buildings. Aid, including food, water, medicine, blankets, and temporary shelters, were brought from USA and the Dominican Republic, which are neighboring countries. The UN and USA provided security to maintain law and order and also to ensure a fair distribution of aid. The UK's Disasters Emergency Committee, the DEC, raised over £100 million to support the 1.2 million people affected by the earthquake to provide shelter, medicine, water, and sanitation. 3/4 of damaged buildings were inspected. These are now secondary effects. 200,000 people received money or food for public work. This included clearing tons of rubble, for example. Several of thousands of people moved away from Port-au-Prince to stay with family or they emigrated to other countries. The World Bank pledged $100 million to support the reconstruction in Haiti. Causes of the earthquake, sorry about that. The earthquake occurred at conservative plate margins. Pacific and Australian plates slid past each other in opposite directions. They got stuck and the sudden release of pressure triggered an earthquake. So effects, again the same key, red is primary, blue is secondary. So some primary effects, 181 people were killed, 2,000 people were injured, hundreds of sewage pipes were damaged, 50% of Christchurch buildings were severely damaged, liquefaction occurred, and this is where the ground gets saturated as pressure within a mass of soil causes soil particles to lose contact with one another, causing damage to buildings and roads as the surface becomes much more softer, so they tend to sink, or the liquefaction material itself is quite runny, so it tends to flood buildings and roads. Part of New Zealand's longest glacier, the Tasman Glacier, was broken off, which created a large iceberg, and 80% of the city was left without electricity. Buildings were out of action for a long time, which resulted in a loss of income and jobs. Schools shared classrooms due to damage, and roads were damaged due to liquefaction, which made it difficult for people and emergency services to move around. People were affected mentally and needed medical support for this, and Christchurch was no longer able to host the Rugby World Cup, so they lost out on tourism and therefore on income too. Responses to the earthquake. People were checked and taken care of to make sure they're prevented from any damage or dangerous buildings. Chemical toilets were provided for 30,000 people. Areas were zoned in green, orange, white or red to classify the level of danger and the cost of repairs. International aid provided $67 billion. New Zealand's economy paid $898 million in building. Homeless people were provided with temporary housing, and water and sewage systems were restored for all residents by August. Roads and houses were cleared from liquefaction, and 80% of roads were repaired by August, as well as 50% of footpaths. Finally, tsunamis. The definition of a tsunami it's a special type of event, often an earthquake, which moves the entire depth of water above it. And how is it formed? They're usually triggered by an earthquake. The primary effect is the crust shifting, and the secondary effect is the displacement of water moving above the crust. The average wave is about 100 meters in length from crust to crust, but the tsunami wave is likely to be much greater, at about 200 kilometers in length, and usually travels at 800 kilometers per hour. They reduce in length and gain in height when approaching the coast. So, case study for tsunami is the Tohoku tsunami in Japan on March 11th, 2011. So, key information: it's 9 on the Richter scale. It occurred 100 kilometers east of Sendai on Honshu, Japan. A wall of water around 40 kilometers in height hit Japan's northwest coast in 30 minutes, and several other places were hit by 9 additional waves, all 10 meters in height. And the tsunami itself, it was considered to be the secondary effect of an earthquake that occurred before that. Causes of the tsunami: as I said, the earthquake triggering the tsunami occurred at the destructive margin, which is where the Pacific plate subducted beneath the North American plate, and scientists believe that a 200-kilometer long segment of rock suddenly slipped, which resulted in an upward flick of the Earth's crust between 5 to 10 meters in length. And some effects of it. You don't need to know all of these, this is just so that you know a lot of them, so you pick out whatever you think is most important to you. So primary effects, 20,000 people were killed as waves swept 10 kilometers onshore. The waves of the tsunami destroyed tsunami defenses and flooded areas which were thought to be safe from tsunamis, which is why the death toll was so high. 2 million people were left homeless, and power lines of gas were ruptured and led to massive fires, as well as water services which severely disrupted as underground cables were ruptured. A dam in the north of Fukushima burst its banks and more homes were swept away. 500 kilometers squared of coastal plains and farmland were inundated. Settlements and communications were also destroyed. Sendai, a port city with a population of 100,000, was completely destroyed as 200,000 buildings were destroyed. 500,000 people were forced to live in shelters. Water became contaminated with typhoid and cholera, and Tokyo's major airport halted all flights, and the Shinkansen bullet train was suspended. At Fukushima power plant, the cables in the plant were destroyed by the tsunami, causing radioactive material to escape. Thus, radioactivity levels increased by 40,000 times more than usual. Japan lost $90 billion in shares, and the total cost to rebuild areas cost $185 billion. So, responses to the tsunami. 100,000 Japanese soldiers deployed in search and rescue. They distributed food, water and blankets to those affected by the tsunami. Specialist search and rescue teams were flown in from all over the world to help. There was an exclusion zone set up around Fukushima power plant, and people were evacuated from this area due to large amounts of radioactive material spilt. Japan and USA joined forces to search for bodies on the eastern coast of Japan. Huge rebuilding programs took place. This involved houses, infrastructure and communication systems, roads and railways, for example. Port facilities also had to be rebuilt. Fortunately, a motorway was rebuilt just a year later, and 116 countries and 28 international organizations offered assistance. The system of the tsunami defenses had to be reconsidered. It is possible that the height of these defenses will increase in height beyond the currently accepted level of 12 meters. So that was the Restless Earth. I've just got a few questions here just to consolidate your understanding. So here are the questions, and then pause the video, have a go at them, and I'll go through the answers in a minute. And there are the answers. So, at a destructive margin, the oceanic crust sinks below continental crust by a process known as subduction. Volcanoes are found at destructive and constructive margins. A difference between oceanic and continental crust. Oceanic is much denser, continental is thicker. Just whatever is correct, really. So what they're made of and how old they are, how young they are, really. Yeah, just have a look at the slide and then that will give you the answer. The epicenter of the Japanese earthquake was 100 kilometers east of Sendai, and two effects of the Christchurch earthquake, any from 181 deaths, 2,000 people injured, liquefaction, 80% of cities without electricity, and just that they were unable to host the Rugby World Cup, or anything else that is correct. So I hope you understand the rest of the stuff now, and if you need any help with anything, or you want to recommend something else for me to do, then just leave in the comments below and I should be able to get it to you within a week. Thank you for watching.